right. Welcome everyone to webinar number 14 of our webinar series. We are ESCOM. We are the Eastern Shore Citizen Science Coastal Monitoring Network. And what we do is we monitor a bunch of beaches up and down the eastern shore of Nova Scotia, hoping to promote coastal conservation and climate resilience. Now, one really important part of that is weather, monitoring the weather up and down the coastline via the use of these personal weather stations that a lot of us have. Being able to use that data both for our own knowledge and for general knowledge for the sake of things like policy or things like climate resilience. Within that wheelhouse, today we've invited our guest speaker, Dr. Armin Nikkhah. He works for Climate Atlantic in science and data initiatives. With over a decade of experience working across a wide range of climate-related issues, he has a PhD in meteorology and a Master of Environmental Management from the University of New Brunswick. He'll be talking to us today about weather stations, what they can do for personal use, and a lot of really great info. So Armin, thank you so much for speaking to us today.
Thank you so much, Abrami and Camilo, for inviting me, and hello everyone. Thank you all for joining. I'm just going to share my screen first. Can you see my slides? Great. So today I'm going to talk about weather stations and best practices basically for personal use or further than personal use. We'll start with a quick story-based overview of atmospheric science and how us as humans have always tried to understand the sky. Then we'll connect this story to the real foundation of modern forecasting and measurements in atmospheric science. After that, I'll get practical information and show you what station measures and how stations are evolved during time and what personal stations can actually do, and most importantly, how to set them up. Where is the best place to use a weather station? So let's start. I want to begin with a simple idea that atmospheric science didn't start as equations that we know today or satellites that are familiar today. It started as curiosity and necessity. Humans have always been pattern seekers, and weather is one of the most important patterns around us. And the key transition in atmosphere science is when we have moved from signs and stories into repeatable measurements. That shift has turned our knowledge in weather and atmosphere to atmospheric science that we know today. As I mentioned, always interesting for us as humans to understand weather for very it started from survival, traveling, farming, trades, and just wanting to know what comes next. And weather and climate affects decisions for every time scale. As you can see, if we start from minutes and hours, it starts with storms, wind gusts, and visibility, lightnings, and hazards like that. If we jump into days, we shift into shipping situation, transportation, outdoor work, shoveling your snow from your backyard. And if we move into seasonal scale, it affects our water supplies, planting schedule, farming schedule, heating and cooling demands. And for long term, it shows us climate risks, global warming, planning, and how to adapt to the situation. So also this famous ancient example from Greece in Athens is a great example that how our ancestors were interested into weather and the changes in the weather. Basically, the Tower of Winds in Athens combines wind vane and timekeeping situation, which reflects how important weather and climate was to early humans and our ancestors. Our journey to forecast weather always also had some weird practices associated with them. And sometimes before instruments, people used patterns and lore. Sometimes those patterns are loosely connected to the real physical aspects of our atmosphere. So they were not dependable to measurements and actual physical situation of the atmosphere. If I want to give some examples, for example, for some people, red sky at night can sometimes line up with certain mid-latitude weather patterns as like short time precipitation situation, or some people used to analyze animal and plant behavior to reflect how is the weather going to be. But in fact, animal and plant behavior does have high level of other factors that can affect that behavior. It does have high amount of noise, and there are so many factors that can affect that. But eventually, science started to step in that circle of assumptions and understanding, and we will look into that. But as I mentioned, many of these methods were unusual, weird, and not science-based, which for fun, we still continue some of these methods. If I want to show you an example, is a Groundhog Day. We still do have Groundhog Day. And in fact, Phil the Groundhog, the most famous one, we do have other groundhogs in Canada, I guess, really, and we do have several groundhogs that forecast weather. Actually, Phil does have 45% accuracy. And that's a very important reminder to us that whatever that is statistically offered to us is not going to be physically accurate. If I want to give you a simple example, for example, I can make a statistical correlation between the color of shirt that I'm wearing every day and the chance of that very day being rainy. And many times that correlation can be meaningful. But if I think, is it physically possible to make a correlation between the color of my shirt and the chance of that day being rainy? So it's really important that whatever statistical methods we use, it's important for that statistical method to have scientific physical backup. But this was the very point. A weather station was the very start point that our modern atmospheric science started. This slide is where the story turns into. They can count on those data to understand the situation of our atmosphere, the situation of our climate, and quality control that observation, and then analyze the data, and then in modern atmospheric science, give those data to our models and forecast the weather as we can see on our mobile apps today. But let's jump into the history of our weather stations that Camilo mentioned that all of you do have one on hand. Let's see how this story started. So the core idea is weather station is simply the state of atmosphere at a given time and a place. So we started measuring variables that control that state. We measure usually pressure, temperature, wind, and precipitation. These are the most common variables that we access within a weather station. And a classic milestone there is a mercury barometer, which was invented in 1643, showing that air has weight and pressure, a pressure that we are feeling as humans from the very time we start living. And without that pressure, we cannot live. It's part of our environment. So this is the big jump that stations don't just measure the atmosphere. They create a network. Weather stations are connected together through an organization which we know as World Meteorological Organization. Once you have a standard instruments and shared observation, you can build maps, you can build forecasts, you can build forecast services, and then you can build climate records. And then you can understand that within those climate records that you have collected since 100 years ago, the climate is changing. The timeline here highlights a few turning points from barometer to telegraph connection and forecast services and standardized modern atmospheric science as we face today. And this is why stations matter very much. This is why weather stations are so important, because a standard observation, an ensemble synoptic map, and storm warning systems and long-term climate records detect all of these trends for us to understand our atmosphere and how is it going to react in the future. In other words, meteorology became operational when observation systems started from weather station became systematic. So let's take a look, take a deeper look at some of the most common variables that a weather station actually gives us, and we usually monitor through weather station. The first one is, of course, temperature, which influences heat stress and frost risk, or also atmospheric stability. In addition to that, we do have humidity, which links to dew point, fog, evaporation, and icing risk. We do have pressure, which is kind of a central variable for storm tracking and synoptic patterns. We have wind and wind speed and direction, which matters about wind hazards, especially in coastal regions, which we always do have winds. And in addition to that, we always monitor precipitation, but based on the model of the weather station and based on the practice or sector that weather station is designed for or used for, the weather station can have additional sensors. For example, if you're in agricultural sectors, you can have soil temperature monitoring in different levels. If you want to understand the amount, again, in agriculture or similar practices, or you're interested to install a solar panel on top of your roof or in your backyard, you have to understand how much solar energy are you receiving during different times of the day, different times of the year. But in addition to these sensors, if you're interested in hydrology, if you're from different sectors, you can have additional sector-specific sensors installed on a weather station. So, weather station, as we mentioned, basically started from simple measurement systems, which were usually manual. So, first generation of weather stations were all manual weather stations, meaning that a person was at the weather station all the time to report weather to WMO. If that weather station was connected to the network, they had to report it 6 times a day, or in some cases, in more advanced weather stations, they had to report the weather 12 times a day back in 70s. And so like like aviation monitoring system. They switch shifts to run that weather station 24/7. But eventually, as we upgraded our systems, weather stations became fully automatic, and they do all the work by themselves. Sometimes they just need maintenance and calibration. So basically, we started from manual weather stations, manual products, to fully automatic weather stations. Now, many of you do have and can have in your backyards. But when you check online to buy a weather station or to get a weather station, there are different versions of weather stations. They start from $80, $70 or cheaper, up to $20,000. What's the difference? What's the difference between a professional weather station and a regular weather station that I can have in my backyard as the daily use weather station? This is where I want to be very clear. Consumer and professional stations are measuring the same atmosphere, but they don't operate on under the same system. Professional stations, like the ones Environment Climate Change Canada does have, or airports do have, or research stations use, often have broader sensors which suits, and sometimes they significantly reduce any bias. So they have very high accuracy. They follow strict settings, standards, and documentation procedure, which regular weather stations do not have. They typically have traceable calibration and scheduled maintenance, so to make sure all the data is very accurate. And data quality control is another layer that automatic weather station, professional weather stations do have by maintaining their metadata. But on the other hand, regular station, or we know it as consumer stations, can still be very useful. But quality becomes very dependent on the position of the station, maintenance of the station, and the data. So what are the benefits of a personal weather station? So a personal station are very valuable because you can understand your microclimate. Because around your location, you may not have a standard weather stations. Many locations, many rural areas, if you're far away, you don't have a standard weather station. So it's good to understand your own climate. For example, if I want to give some example of personal use for gardening, irrigation scheduling, outdoor safety, better awareness of wind, of chills, what I'm supposed to wear today during the winter. So these are really great examples for personal use, and commonly values is real to personal stations can still fill the gaps between official stations which support monitoring of the globe and my personal needs in my backyard. But again, this only works when the station is situated in the correct place and maintained on a regular basis. So to look into best practices and where to best position for a better station to be at, it's better to understand the situation of the way that I want to understand the variables that I want to monitor with my weather station. If temperature is really important to you, it's highly recommended that the weather station is installed 1 meter to 2 meters above the ground, because when it's close to the ground, it's affected by the solar radiation and the solar radiation which reflects from the ground. But in your case, you want to monitor the actual air temperature, not the ground temperature. That's why you need to give it some elevation from 1 to 2 meters for monitoring temperature. But it's kind of the same for rain. You just have to elevate it enough so when the water hits the ground, don't goes back to your measurement cylinder. But for wind, if you want accurate results, you have to go up to 10 meters or something like that to get the actual accurate wind results. So the most challenging part is always with the wind, whether you want to have accurate wind information and weather pressure situation, or you're satisfied with temperature and precipitation. But let's look at some common mistakes that we may make when we are installing weather stations. One of the most common mistakes is installing on the roof, because roofs are usually shinglings or metal roofs. They do have very high amount of reflection, and they produce heat, and they can reduce the accuracy of your data significantly. You're not supposed to install a weather station near walls or vents, because they usually do have warm exhaust from them and reflect radiation that can change your data accuracy and put bias in your readings. A weather station is not supposed to be installed over concrete or asphalt or other materials that can create warmer microclimates than surrounding areas. Or it's not recommended to install a weather station around trees when the wind is broken into shallow situation, because then the weather station is not reflecting the actual wind speed to you. About rain gauge, it's very important that the rain gauge be fully leveled, and because if it's tilted, the bucket will mismeasure the rain exact millimeter. And another very important item that you should always consider in your weather station is maintenance. Let's jump into maintenance. Optional if you want a trustworthy data. A simple monthly or seasonal routine goes a long way. We always need to clean our weather stations, because when dust builds up on our sensors, it reduces the data accuracy significantly. And we have to, if you have actinograph, if your weather station does have radiative monitoring situation, if your weather station does have albedo graph, you should always clean the graphs. If your weather station monitors or operates with solar radiation, you should always clean the panel, because I've seen in many cases when we put the dust starts building up on the panel, and the weather station after some time loses power if it doesn't have power supply. It's also very important that we control vegetation growth, basically tree growth around our weather station, so that it is not positioned in the shade of a tree, or also trees and vegetation can reduce the temperature in summertime. So when it's close to a tree, it basically gives you a lower number than the actual situation. And if you're monitoring rain or precipitation, it's very important that you monitor cleanness of your gauge, because usually sometimes the sensor that empties the gauge doesn't work, and birds do have tendency to go around precipitation monitoring systems to drink water from them, and then they will make the space dirty, and the debris starts building up on that, and it basically the bucket will be useless for monitoring precipitation. But how can I use my weather station data? What's the benefit of weather station data? This slide basically explains how personal stations can become more than a gadget. If a station is well situated and well maintained, then networks can apply quality control and store metadata. And you can also, there are some websites that you can use to contribute your weather station data to your community. And we can learn real local patterns like heat, rain, and wind gradients, and local researchers from your province can significantly benefit from your weather station data. One of the examples in our work is examples of adaptation, which urban heat situation, urban heat monitoring can be really beneficial when there are dedicated local weather stations around, or in case of monitoring flooding, because flood monitoring can be really detailed and complicated. These dedicated personal weather stations are really valuable in monitoring flooding, because the precipitation pattern on an area can vary from one location to another location within 1 kilometer or 500 meters. So as many as weather stations are around to monitor the situation of the precipitation, the data gets more valuable and valuable, because it gives the hydrologist and hydraulic analyst to have full understanding of the situation of the watershed. And based on that data, they can actually design your culverts and sewage systems more accurate, so there is no flooding situation if you live in urban areas. But we have to always remember, the weather station is one of the examples of a great number of monitoring systems that we have across our globe. In addition to weather stations, we do have ships, we do have aircrafts, which are fully monitoring our planet 24/7. And on top of that, we do have satellites and data centers for analyzing this data and monitoring the accuracy of this data. Now, modern, some of them which are installed in faraway areas, like in northern areas, they don't need much more calibration anymore, because they're connected to satellite data, can calibrate the weather station itself, and they just require 6 months or 3 months maintenance, because they're connected to other network systems. And all of the data from all of these observation systems are shared with, in our case, is shared with Environment Canada, and Environment Canada shares the data with World Meteorological Organization, or WMO, and WMO shares all the data for free with everyone. And that's how, that is exactly how that we can predict our weather, and we can receive our weather forecast on our phones every day easily. Thank you so much for all of your questions. If you may have any, I will stop sharing.
All right, thanks so much for the talk. That was amazing. We do have a couple of questions. Well, we have one question. If wind sensors need to be 10 meters above the ground, but other sensors need to be at 2 meters above the ground, how do we manage that difference?
Well, yeah, that really depends on the model of your weather stations. Many weather stations come with 2 separate sensors for wind and other variables. So usually the very personal weather stations which are available on Amazon or regular websites that we buy from, they are combined. So it's recommended to install them something in between, so that you have accurate results for both measurements. It would be, again, challenging for measuring precipitation, because it needs to be somewhere that you can reach it to maintain it.
All right. Robert asks if there are any recommendations for weather stations that you have?
Robert, if you're referring to the brand or website,
or model.
I honestly do not have recommendation, because recently the number of companies that started building and creating weather stations significantly increased. And I honestly do not have a recommendation, because in my case, wherever I've worked with, they usually use professional weather stations, and they can be really pricey. and each module is separate.
Right.
So I do not recommend that for your use. But aside from that, I guess Camilo can answer that question much better than me.
I've got 3 different ones currently: a Davis, ambient weather, and Accurite.
My recommendation is that you can test them. For sure, you do have weather station, local weather station at near point, somewhere within at least 10 kilometers around you. You can test which one is more accurate.
Now, one of those is actually located in the U.S. The other 2 are located at my house here. But
Okay.
unfortunately, right now, the windstorm from a week or so back broke the rain gauge on the Davis, and the temperature sensor just went out on my ambient weather.
Yeah, one of the main challenges with cheaper models that I've experienced is that the sensors, especially temperature sensors, lose their accuracy when the weather gets really cold.
Mm-hmm.
I've monitored that. So this is something that I highly recommend, that you always monitor your weather station results at some point. Consider it as a calibration with your nearest Environment Canada weather station.
Okay. All right.
Yeah, and I would like also to give some comments about these questions. This question from Robert, and is first, the thing is that in our experience in ESCOM, I did a research in 2024 about weather station, commercial weather station. I think it's very clear for most of the people that I consult about this weather station. They say Davis. This is a great brand, but this is not really cheap. I think it's around $1,000. Normal weather stations. So sometimes, I think most of the time, they are too expensive. At least if you are starting, maybe
Right.
you have some experience. It's good that you can upgrade your weather station, but in our case, we were looking for weather station below 200 Canadian dollars. So
Yeah.
we are working with the same brand, not because we analyze this brand, we compare, just because it has good comments on Amazon. And we need to say that after, at least in my case, I think most of us, my weather station have been active since July 2024, and still today is working perfectly. So I can say that is good. However, I would like to add that there is one brand that is called EcoWeed. That something that I discovered recently, very interesting, is that first, as I know, but I'm not totally sure, most of the brands, the manufacturer is EcoWeed. So they rebrand these
Right.
EcoWeed stations. However, when you want to buy an EcoWeed station, it's more expensive than the brands, the other brands. However, one good thing, and I think it's related also with my question about today I'm really surprised and I learned a lot with this idea that different altitude for the wind sensor with the temperature sensor, is that EcoWeed has the big advantage that it's modular. You can buy the different sensors.
Right.
So I think this could be, some kind of a grade. So to have these weather stations that you can buy the different sensors and you can put all together, but of course it needs some skills related with weather stations, because the configuration thing this is a trick.
I know the Davis that I have is the less expensive one, which is the $1,000 one. The one that's modular is the next step up, and maybe after this one, the windstorm knocked it down, and the one sensor stopped working. So,
and I think I will add also, when we choose the weather station, we are still in ESCOM trying to find a brand that we can recommend. We cannot recommend anything now because we're still in that. But I think it could be also some kind of advertisement in the future. Someone watch this video. We would love to have some kind of agreement with a brand that will receive some special treatment. That may be some technical support. But until today, our plan is that we are using this personal weather station, not the cheapest. I used to say that less than $100, it won't be, it's too cheap to be good enough, but
Right.
in this range, $100, $200 is fine. But at the same time, I will promote that we start learning more about the different weather systems, because this is also some restriction. Maybe we buy a weather station that looks nice, but when we want to connect to, there are three main weather services. Wonderground is the Accurate, I think, and the other is the weather cloud, if I remember. So these are weather systems that is important that we can connect our weather station to one of these systems. Otherwise, we won't be able, as a citizen scientist, to download the data and to compare, and also to the idea of to be a network is that, just our example in Dover, we have three ESCOM weather stations in Dover. Now we have a really better weather forecasting for Dover, because we have three. We can know our microclimate. So this is also a call that I will invite all of you to invite your networks, your neighbors, to buy a weather station, because you will be more accurate if you have more weather station in your areas.
There are some questions in the chat that I'll try to answer. The first question is that how to calibrate our personal weather station? How often should we do it? So it really depends on the sensor first. If it's temperature and humidity, the best approach is the one that I suggested to Robert. It's to find a known reliable reference, whether if it's a nearby ECCC weather station, or for example, from where I am, libraries do have very high quality thermometers and hydrometers. You can borrow one from your local library to make sure if your thermometer or humidity meter is accurate. And the other thing for thermometers is to make sure the sensor is as I said, placed correctly, far away from walls, roofs, or pavements. And usually for temperature sensors and humidity sensors, it's recommended from 3 to 4 months of maintenance. And for rain gauge, as I mentioned, keep it level and clean. And because usually leaves go in there, get in there, insects get in there, and dirt causes big error and wind. And remember, the gauge for the rain is basically a bucket, a container. You can simply pour water into a measurement device and pour the water from measurement device to your gauge to make sure that your gauge is showing the exact right number as you've got from your measurement device. For pressure, it's actually the quality of sensor. There is not much calibration that you can do aside from cleaning your weather station. It's usually, when it's a good quality weather station, it's usually stable and the pressure doesn't change. And for wind calibration, the most issues with wind sensor is dirt and icing. Sometimes the weather gets really cold that the material which was used to build that wind monitoring sensor that changes under the cold weather, and it reduces accuracy, or it gets really icy and it just freezes. So you have to make sure that it doesn't freeze. So basically, for simple rules, like light checking every month to clean it, to make sure it does have a battery if it's battery operated, and for seasonal, compare your seasonal results with a reference. And for each year, maybe check if your rain gauge is stable and it doesn't have much dirt.
Sorry, I mean, I just want to add, just because I remember, maybe we can also start checking the weather station, the other ESCOM weather station in our area. So just to give an example, again, in Dover, we have 3 weather stations. If in my weather station, for example, say the precipitation was 2.5 millimeters, but the other 2 weather stations were 4, maybe my weather station needs to be calibrated.
That is correct. And there's another question. Is it accurate to check your weather stations against a device like a barometer or a thermometer that you have? For barometer, yes. If it's a good barometer, you can check your barometer results with that. But for thermometer, it's really important because the thermometer within the weather station, even the personal weather station, it's covered in a shield, because to avoid it from exposure to sunlight. So if you have a thermometer that you want to compare the results, you have to also put that thermometer as the same height level as your weather station, and also put it in a screen which we know it as a weather station screen, which is basically a box that sunlight cannot get in, but air can get in, because you're measuring air temperature. For example, what my car shows me is not an accurate measurement to compare with my weather station.
I think we have 3 more questions there on a comment in the chat.
Yeah, we have, what is the thought on how we can leverage the data that we're generating?
As I mentioned during the presentation, there are some NGOs and websites that you can basically contribute your data to them. You can connect to these websites or NGOs to contribute your data to them. And usually universities like Dalhousie and UMB do have researchers who are working on the atmospheric researchers, which they would love to have your weather station data.
So I guess that's my question. That's fine, but I guess from an ESCOM perspective, Camilo, what are your thoughts? Like, I mean, I'm happy to plug into whoever, but someone might want to come out and say, well, your weather station isn't actually calibrated properly, or it's not quite right. So we're kind of interested in some of your data, but not all of your data. I mean, it's neat for me to know, how much it rained yesterday or last week or a month ago. But part of the objective was to contribute to your good, I guess.
Yeah, but I think just now that you already direct the question to me, so I will give some quick answers. The first one is that the idea is that we as a network, we can share our data. We are close to have our web data management platform. So all of us, we will be able to download our own data and also to make some simple graph. Part of our plan is that hopefully at the end of the year, we will have a list of a list of prompts so that we can start doing some analysis with AI with this data, so that we can really analyze the data as a citizen scientist. This is internal. Externally, one of the purposes in ESCOM with Dalhousie that is supporting from the scientific part, the network, is that these researchers that are working on our topics, the beach profile, weather station, beach flora, they can use this data. They can use our data for generating new knowledge. Of course, they will need to acknowledge that we are the owners of the data, we are the owners of the weather station, of course, but I'm sure that it won't be a problem about that. But this is also an invitation to researchers, initially in Dalhousie, but of course, all around the world. If you want to work with our data, we're very happy to do it in general terms. The idea is that we can also want to learn more about how they are using the data. And finally, last but not least, also the idea that in someday we can complement Weather Canada data, because it's so difficult. I think I really thanks our guest speaker to explain very clearly, very simple, how weather stations work and the difference between this professional weather station and our personal weather station. So now we know that on the Eastern Shore, we only have 2 weather stations from Weather Canada. But we as an ESCOM, now we have 16 weather stations and growing. So our goal is that in the future, we will, and this is also why we wanted to have this connection with Climate Atlantic, and our guest speaker is working on that, is that in the future, we can complement the provincial data and the federal data so that we will be also part of this better forecasting for everyone. So this is, in general terms, the 3 levels of our goals with this data.
Okay, so stay tuned. Essentially, gotcha. Okay, sounds good.
And we have one more question. Anne asks, my weather station is offline. How do I get it back online? And do you use the RADI weather stations? The RADI weather station connected to...
My weather station's connected to Wonderground.
Yeah.
And Camilo had asked me for my EPI address. So normally I just use the app on my phone. So I had no idea that it is offline because I had to go into my laptop to get to the app to find it. And I tried to reload it so that it would be back online, but that didn't seem to do anything. And maybe this is a message for Camilo, I don't know.
Thank you, Anna. I think it's great, your question, because even looks like it's something very particular. I think it's great for us as a network because this is one of the things, and again, I just would like to mention the things that we are doing this year, especially with Abirami. This gamification strategy that is also, it was our webinar in August, is part of that, because we need, as a citizen scientist, to learn also how to use these different variables. So one of the ideas is that we as a user of weather stations, we can learn how to, for example, this looks like it's something simple, it's offline, have to be online, but it could be quite more complicated because we need to know what is the cause of it's online, it's offline. One of the things could be because it lost the connection with the Wi-Fi, because our weather station connected with the Wi-Fi. It could be, and it happened quite often with Wonderground, that is not connected with the Wonderground, so it's offline just for a short period of time. Another reason, it is part of my comment in the chat, is that I will suggest to add to our maintaining checklist, change batteries, especially during winter, because our weather station working with 3 AA batteries. Okay, there are just batteries. We need to change them, and especially when in the manual in our RADI station, it said, especially in winter, try to use some special batteries, or at least change them, because low temperatures affect the batteries, especially with the normal batteries that we used to use, the alkaline batteries. So this could be another reason. But I think more than the specific situation now, I think this is a great message to everyone, that an invitation that we will need to learn more about our weather station and take care of them, and know these troubleshooting things. So also we can support others. So it would be great that that if Anne has this situation, she can ask Leon, or maybe Robert, that has more experience with weather station and it's not too far from Anne. And maybe Robert can help Anne how to solve this situation. So, I'm very grateful, with your question, Anne, because I think it's very interesting for us as citizen scientists.
If anyone else has any questions, feel free to raise your hand. Shout them out now. If not, I think we can bring this webinar to a close. Armin, again, thank you so much for coming on and talking to us about weather station setup and also weather station history, and also how we can use weather stations and apply them in our daily lives. And have a good rest of your night, everyone, and month. See you all in the next webinar.
Okay, thank
Thank
you, Olivia.
you. Bye,
Thank you, everyone.
everybody.
Bye.
Bye.
Yeah, have a good night.